Okay, so problem number 35. Let's just make this appear. Okay, the directions say find the slope of the graph of the function at the given point. Use the derivative feature of a graphing utility to confirm your results. So, what I am going to do is I'm going to try and find out what y prime is equal to using only the sum and difference rules and the power rule, right? Which are the only things that we've learned from section 2.2. So what I can use, right, because I don't have anything that I can use the power rule on this yet, so what I'm going to do is I'm going to see if I can figure out what this is equal to in a form that I can use the power rule. So this is equal to 4x plus 1 times 4x plus 1. And when I distribute this, right, first outside, inside, last, so 4x times 4x, 16x squared, outside plus 4x, inside plus 4x, last plus 1. So this is going to give me 16x squared plus 8x plus 1. Now it's in a form that I can figure out what that is. And I guess I shouldn't write that y prime is equal to that. That is just equal to y right now, right? So then now I have it in a form that I can use the sum and power rule, right? So if I want to find y prime, or the derivative of y with respect to x, now I can use the sum rule, figure out what the derivative of the first term is. So that's 16 times 2 times x to a 1, right? If I bring down the 2, subtract the power by 1, this gives me 32x. The derivative of x is 1, so a constant multiple of that is 8, and then the derivative of 1 is just 0. So this is what y prime is equal to. And I want to know what the tangent line is as my function passes through a point of 0, 1. Is that true? Yes. Okay. So then what we have to do is figure out what the derivative is equal to at that point of x equal to 0, right? So our y prime will be equal to 32 times 0 plus 8 equals 8 at x equal to 0, right? So if I were to graph this right now using a graphing calculator, using like your TI, what have you, right, I would probably get a function, a parabola, right, because we have a square quadratic term there. So this is going to be, where's my little graphing thing that we looked at before? Edit, I wonder if I can clear this graph. I don't know how to do that. Let's see if I can pause this real quick. Okay, I couldn't figure that one out, so I just went to that ggraph site that we were talking about before and used their applet version off of their website. Okay, so this is the function y equals quantity 4x plus 1 squared. So we have it right here, and we want to know what the derivative is for x equal to 0. So if we zoom in on this, let's zoom in. And let's zoom in again. I wonder if we could square zoom, maybe? That's what that is? No? No. Zoom in. Okay. So as x gets to this value right here, right, we want to know a tangent line that goes through this point also that matches the rate of change of the function for x equal to 0. The rate of the change of the function should be a value of y prime equal to 8 at x equal to 0. So let's try to figure out what the equation of that line is. So let's look at that. So we have our slope, which is equal to our derivative at that point, and a point equal to 8 and our xy point, which is equal to 0, 1. So a line that goes through 0, 1, and they get the 1 by putting a value of x equal to 0 into this equation and then figuring out what y would have to be equal to. We know that our line is equal to y equals mx plus b, and the y here is, maybe I'll put it with a little star subscript there, going to be, let's see here, 1 equals m, which is 8 times 0 plus b, so this means that b has to be equal to 1. Okay. Alright, so this means, let's see, that, I don't know how that happened. Let's see, our function y is going to be 8x plus 1. So let's see, in our graphing calculator, if we put that in, let's see, 8 times x plus 1. Right, so I put that right in there, and if I hit enter, yay! Right? We have a tangent line that passes through 0 exactly at the same inclination or rate of change as our function quantity 4x plus 1 times x squared. And this is the kind of answer that you should see when you put it in your graphing calculator. Okay, and that is problem number 35.